All right, here we are, managing growing projects. Okay, let's read through this. As you write large programs, organizing your code will become increasingly important. By grouping related functionality and separating code with distinct features, you'll clarify where to find code that implements a particular feature, right? The programs we've written so far have been in one module in one file. As a project grows, you should organize code by splitting it into multiple modules and then multiple files. A package can contain multiple binary crates and optionally one library crate. As a package grows, you can extract parts into separate crates that become external dependencies. This chapter covers all these techniques. For very large projects comprising a set of interrelated packages that evolve together, Cargo provides workspaces, which we'll cover in the Cargo Workspaces section, chapter 14. We'll also discuss encapsulating implementation details, which lets you reuse code at a higher level. Once you've implemented an operation, other code can call your code via its public interface without having to know how the implementation works. The way you write code defines which parts are public for other code to use and which parts are private implementation details that you reserve the right to change. This is another way to limit the amount of detail you have to keep in your head. A related concept is scope. The nested context in which code is written has a set of names that are defined as in scope. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name at a particular spot refers to a variable, function, struct, enum, module, constant, or other item, and what that item means. You can create scopes and change which names are in or out of scope. You can't have two items with the same name in the same scope. Tools are available to resolve name conflicts. Rust has a number of features that allow you to manage your code's organization, including which details are exposed, which details are private, and what names are in each scope in your programs. These features, sometimes collectively referred to as the module system, include packages, cargo feature that lets you build, test, and share crates, a tree of modules that produces a library or executable. Okay, packages let you build, test, and share crates. Crates are a tree of modules that produce a library or executable. Modules and use let you control the organization, scope, and privacy of paths. And paths are a way of naming an item, such as a struct, function, or module. Paths. Interesting. In this chapter, we'll cover all these features, discuss how they interact, and explain how to use them to manage scope. By the end, you should have a solid understanding of the module system and be able to work with scopes like a pro. Sure. Okay. Packages and crates. We are at 7.1 here in the book. The first parts of the module system we'll cover are packages and crates. A crate is the smallest amount of code that the Rust compiler considers at a time. Okay, even if you run rustc rather than cargo and pass a single source code file, as we did all the way back, the compiler considers that file to be a crate. Crates can contain modules, and the modules may be defined in other files that get compiled with the crate, as we'll see in the coming sections. A crate can come in one of two forms, binary or a library. Binary crates are programs you can compile to an executable that you can run, such as a command line program or a server. Each must have a function called main that defines what happens when the executable runs. All the crates we've created so far have been binary crates. Library crates don't have a main function, and they don't compile to an executable. Instead, they define functionality intended to be shared with multiple projects. For example, the rand crate we used in chapter 2 provides functionality that generates random numbers. Most of the time when rustaceans say crate, they mean library crate, and they use crate interchangeably with the general programming concept of a library. The crate root is a source file that the Rust compiler starts from and makes up the root module of your crate. Okay, we'll explain modules in depth in the last section. A package is a bundle of one or more crates that provides a set of functionality. So package has multiple crates, single or more crates. Okay. Package contains a cargo toml file that describes how to build those crates. So packages have dependencies, I think, right? That's why they can include more than one crate. Cargo is actually a package that contains the binary crate for command line 2 you've been using to build your code. Cargo itself is a package. The cargo package also contains a library crate that the binary crate depends on. Other projects can depend on the cargo library crate to use the same logic the cargo command line tool uses. A package can contain as many binary crates as you like, but at most only one library crate. At most only one library crate. Okay, interesting. A package must contain at least one crate, whether that's a library or a binary crate. Let's walk through what happens when we create a package. First, we enter the command cargo new. Right. I've done this quite a few times. Not going to do that again. After we run cargo new, we use ls see what cargo creates. Ls, really? Is that the thing in? Okay, you can use ls in PowerShell as well. Nice. I've been using DOS commands. We use ls to see what cargo creates. In the project directory, there is a cargo toml file giving us a package. Right, cargo toml file right here. And then what? There's also a source directory that contains main rs. So ls source main rs. There we go. Cargo follows a convention that source main rs is the crate root of a binary crate with the same name as the package. Likewise, cargo knows that if the package directory contains lib.rs, the package contains a library crate with the same name as the package. Okay, and lib.rs is its crate root. Cargo passes the crate root files to rustc to build the library or binary. Here we have a package that only contains main.rs, meaning it only contains a binary crate named my project, because that's the name of the project, right? If a package contains main.rs, here my project is called Rustbook, by the way. So for me in my system, that's the name of the package. If a package contains main.rs and lib.rs, it has two crates, a binary and a library, both with the same name as the package. A package can have multiple binary crates by placing files in the source bin directory. Each file will be a separate binary crate. Okay, defining modules to control scope and privacy. Let's continue on in the next video. Yes.